In lesson 3.4, we're going to look at something called linear programming and then finding maxes and minimum values for different regions. This kind of ties into where we enclosed the figure in the last lesson and found the vertices. It's what we're going to have to do to find the maximum and minimum values. First example we're going to look at here is a bounded region. It asks us to graph the following system of inequalities. Name the coordinates of the vertices of the feasible region. Okay, so it's going to enclose a region. And then find the maximum and minimum values for the function f of the coordinate xy, and then this is the expression, 3x minus 2y for that function. So what we have to do, and we're given three inequalities, this is x and a number, so this is a vertical boundary line, okay, at x equals 5. So what we're going to do is we're going to graph x equals 5. Let me graph my line. It would be solid. So let's grab a vertical line at x equals 5. So it's going to be right there. And we are going to shade. Now you can't shade above and below a vertical line because there's no y in this. So you can't use those shading rules we've talked about. But you want to shade where the x values are less than or equal to 5. So that would be to the left of this. So that's everything to the left of this. That's where the x values are less than 5. Let's go to the next one. Y is less than or equal to 4. No x in there. So that does not mean 4 is the slope. That means it's a horizontal line. Remember, y in a number is horizontal. And we're going to shade below on this one. This one we're shading to the left where the x values are less than 5. So, and these are going to be solid also. All three of these are going to be solid boundary lines. So we're going to draw a horizontal line at 4. So let's draw a horizontal. I'll make this one purple at 4. So basically right there. And we're going to shade below. I'll do that in blue. So we're shading everything down here below the line. Now this last one, notice has both x and y. We're going to solve for y, so I'm going to subtract x from each side. So y is greater than or equal to, it should be negative x plus 2. So that's y-intercept. This is in slope-intercept form. The y-intercept is 2. The slope in front of x is a negative sign. That means negative 1 over 1. So we're going to go down 1, right 1 from our y-intercept of 2. And we are going to shade above, and it's a solid boundary line. Again, all of these are solids. So let's go ahead and graph that. I'll do black this time. Y-intercept is 2. Down 1, right 1. So down 1, right 1, down 1, right 1. Up 1, left 1, up 1, left 1. So what I do is I continue until I get, okay, right there, and it would go there. So let's draw that solid line. Let me grab my line. Oh, let's use blue on this. So we're going to come like this. And it's a solid line. We are going to shade above. So if I do black, I'm going to shade above. So as you can see, above that line would be here. So what we've done, and I'll draw this in green, is enclose the figure. Here is my boundary lines, down to here, and right here. There is the region we're talking about. That is what we call a bounded region. It doesn't go on forever. It's totally enclosed. Okay, we'll look at the next one and what happens with an unbounded region. So we want to look at these vertices. This point and this point. The max or the min is going to occur at the vertices. So what I suggest you do is organize things in a table. So we're going to make a table here. Let me grab a shape here. Let's grab a rectangle. So here's what I would suggest doing each time when you're dealing with these. Alright, divide it into 3 columns. Here's what I mean. We're going to divide this into 3 columns. Okay, and the first column we're going to call the vertices. So I'm going to put x comma y. In the middle, I'm going to put the expression, and that will change for each problem. So in this case, the expression is 2x plus 3y, and then this is going to be the output of the function. I'm going to call it f of the coordinate xy. Now in this case, we have 3 vertices, 3 corners. That's a triangle. It's actually a right triangle. So we're going to have 3. Sometimes you will have more than that. Could be a quadrilateral where you'd have 4. So let's write down, and it doesn't matter what order you put these in. Let's do the coordinates of this point, which would be -2, comma 4. Let's do the other one up here, where the right angle is in that right triangle. That would be 5, comma 4. And then the last one is 5, -3, this one down here. So the max and min values are going to occur at one of those. So here's what we need to do. This says plug in your x and y values into this expression right here. Oops. Let's undo that. So there's the expression, so I'm going to do 2. So I kind of create this middle column to show your work. And I would suggest organizing it that way. Plus 3 times 4. So that's -4 plus 12. -4 plus 12 would be 8. So that's, this is your f of xy. I wrote that up a little high, so I'll rewrite it there. So that one's 8. I'm sorry, I have the wrong expression written down. Looking at my next example. So let's erase that. Excuse me. Let's erase that and get the correct expression written down. The expression here is 3x minus 2y. I was looking at my next example. So it's 3x minus 2y. So those are still the vertices. Those are still right. So it's going to be 3 times -2 minus 2 times 4. 3 times -2 is -6. And then minus 8 will be -14. -6 minus 8 is -14. Okay, so then I do 3 times 5 minus 2 times 4. So that would be 15 minus 8, which is 7. And then I do 3 times 5 minus 2 times -3. So that's going to be 15 minus a -6, which ends up being a plus 6 right here. So this is 15 plus 6, which is 21. So what you want to do is look at these 3. You want to look at these 3 right here. Which one is the biggest? Which one is the smallest? So here's the smallest. So this one, so your minimum is -14. So the minimum is -14. And it occurs, I like to put down the point where it occurs at. Occurs at -2, 4. But the actual value is -14. The maximum, so of those 3 numbers, which one's the biggest? 21 is. So the max is 21. And that occurs at 5, -3. So, you need to put things in your table, be organized. It's a very good way to organize it. Let's go to an unbounded region. Graph the following system of inequalities. Name the coordinates of the vertices for the feasible region. Find the max and the min values for this particular expression for that region. Now if you notice these aren't solved for y. So what we need to do is we need to solve them for y. So I'm going to add x. So 2y is less than or equal to x plus 2. We're going to divide by 2. Divide everything by 2. Y is less than or equal to, that would be 1/2 x plus 1. So there's my first one. Okay. Let's get all of them solved for y, and then we'll graph them. So if I solve this one for y, I'm going to subtract x. So negative 2y is less than or equal to negative x plus 4. We're going to divide by negative 2. Now when I divide by a negative, I reverse the symbol. Negative divided by a negative there in front of the x makes that a positive 1/2 x. And then a positive 4 divided by a negative 2 is negative 2. Over here, solve for y. This one's just one step. It would be y is greater than or equal to negative x minus 2. Don't have to divide on that one. So there's getting all those in slope-intercept form. All right, let's look at the blue one. The blue one here, the y-intercept is 1. The slope is 1/2. It's solid. All of these are going to be solid, and most of these will when you're doing linear programming. It's solid, and then we're going to shade below because it's away from y. So let's go ahead and graph that. Y-intercept is 1. Slope is up 1, right 2. So if I went the other way, down 1, left 2, down 1, left 2. Up 1, right 2 would be here. So let's go ahead and draw that line. Let me grab the line. Let's grab blue. So it's important that you draw straight lines here or repeat your slope over and over. Okay, and we're going to shade below. Now I think I'm going to save my shading till the end. Basically, you'll kind of see, we'll talk about it at the end here, but let's get everything else graphed. So here my y-intercept is negative 2. My slope is 1/2, and I'm not going to put down that it's solid. All of these are solid, but we're going to shade above because the y is bigger. So negative 2, and this slope is the same, notice, so these are going to be parallel lines here. Same or equal slopes, parallel lines. If we go the other way, like that, grab the line. I'll make this purple. So we're going to be just like that. Okay, so right now I'd be above. So if I shaded here, I'd be below the blue line, above my purple. So basically it's in between those two parallel lines right now. Okay, let's go to this last one. The y-intercept is negative 2. There's a negative 1 in front of x, so my slope is negative 1 over 1. Again, this is negative 1 over 1. And we are going to shade above. So if I plot this, negative 2 is my y-intercept, same y-intercept as this line. Down 1, right 1 would be here. Down 1, right 1. I'll repeat that a few times going that way. If I went the other way, it'd be up 1, left 1. Up 1, left 1. Okay, so it's going to go like that. Let me grab a line. Again, it's solid, so we're going to go just like this. And shade above. So we're between those two parallel, the blue and the purple. We're above that line. Above would be up here. So basically, we're talking about this region right here. Now, as you can see, because we have parallel lines here, this goes infinitely that way. It's what we call an unbounded region. Okay? Now we still need to do, so we really only have intersection points. We have these two. Here and here. Okay, so we're going to make a table again. So let me grab my shape. And I'll grab a rectangle. Let's make a table here. So we've got x comma y in the first column. Put the expression in the middle, and I'll use the right expression this time. So it's 2x plus 3y is the expression for this one. And then we've got our f of xy. And you need to make your tables like I'm doing here. Now, as of right now, I'm going to make 3 rows in this, and you'll see why in a second. You got to listen carefully here. So let's do the 2 that I circled here in black. These 2 right here. So one would be negative 2, 0. And the other would be 0, negative 2. Now, what you want to do, because this is an unbounded region, is you want to choose a test point. You want to do a test point for, in this case, a third point in the region. You have to do this if it's an unbounded region. So a test point in the region. So what I want to do is I want to pick a point, and I'll do it in blue, that's in that shaded area. So I'm going to pick, can everybody see that if I pick this point, which would actually be 3, 1, that's in that red shaded region. So I'm going to use, and you can pick anything in there, don't pick any that are on the lines, I'd pick them in the region. I'm going to pick 3, 1 for my test point. So I plug these in just like we did on the last problem. So 2 times negative 2 plus 3 times 0. So 3 times 0 is 0. This is going to be negative 4. Here I have 2 times 0 plus 3 times negative 2. So this would be 0. 3 times negative 2 is negative 6. And if I put 3, 1 in, for my test point, I have 2 times 3 plus 3 times 1. So that's 6 plus 3 would be 9. And what's going to happen as you keep picking points out in that region, do you see how this is bigger than my other 2? So this is bigger than my 2 other vertices, which are the, kind of the corners of that region. That's bigger. That's going to mean this is going to keep getting bigger here as we keep going out. If I keep picking points out in there, that's going to keep getting bigger. So, you're going to get numbers bigger than 9. That means as that keeps getting bigger, as you go down and pick more points out in there, that this has no maximum value. This has no max, and you have to state that. So if they say find the max and min, this has no max, and that comes from looking at your test point and comparing it to your other values. Okay, and you can pick another test point just to see, well, it's going to keep getting bigger, and that as I kept picking points going out this way, that's going to keep getting higher and higher, so there's no max. Okay, which means look at these other 2 values to find the min. Which one's the smaller? Well, negative 6 is smaller. Okay, so this would be the min. So the min is negative 6, and that occurs at the point 0, negative 2. And it has no max. So, and you need to state that instead of just leaving it blank. No maximum, because those points would keep getting bigger.